we shall discuss three keywords which are frequently used along with loops. The first is the break, next is the exit, and finally is the continue keyword or statement. But before we go and take a look at those particular keywords, let us try to understand the need for those particular keywords. Now, at times when you are executing a loop based on a certain condition being satisfied or not satisfied, you may want to come out of the loop. Like, say for example, you're trying to find out if a number is prime. So I start dividing the number starting from 2. Let's say that the number ends up becoming divisible by 7. So when the number ends up becoming divisible by 7, that number can no longer end up being a prime number. That's when I use the break statement to come out of the loop. Sometimes it may so happen that, let us say I'm writing a program, I'm trying to read some data either from the hard disk or from the keyboard. Suddenly there is some error in the hard disk or the file is damaged. In this case, I want to exit or quit my program itself. That's when I use the exit function or the keyword. And last, it is also possible that when I'm running a loop, for certain values of the loop condition, I may not want to execute all the code. That means, let us say for the values of I being 5 and 6, I do not want to execute the statements of the loop. This will be clear when we take a look at example, but just understand, for certain values, if you do not want the loop body or statements to be executed, you use the continue statement. So let's first take a look at the break statement or the break keyword. So what it does is, instead of going here, let's first take a look at a program and then come to the break. It makes our life a lot more easier. So here what I'm doing is, using a C++ program, I'm going to find out whether an input number is prime number or not. For the sake of this program, without getting into too much of maths, I am going to assume 1 is a prime number. So 1 is a prime number, 2 is a prime number, 3 is a prime number, 5, 7 and so on. So what I am going to do here is, I am going to read a number from the user. Then I am going to take another variable or another memory location with the initial value 2. I am going to try to divide the number I have read with 2 first. If it is divisible and the remainder is 0, then straight away it's not a prime number. Then I increase 2, I make it 3, then I make it 4, I make it 5, I make it 6, I make it 7, all the way up till number by 2. Why do I stop at number by 2? Because the last divisor of any number can only be equal to half of that number. Let us say the number is 50. What is the last number which you think can divide 50? It is only 25. So beyond 25, I will not try to divide because it's a waste of computing. This program is definitely not the best way to do or find out a prime number, but it is used to explain how the break statement works. That's why I'm using it here. So what I am doing here is, n is going to read the, or it's going to store the value whose we are going to determine whether it's a prime number or not. The reason for I and status shall be clear very soon. I'm going to ask the user enter a number. Okay, let's say the user enters a number 31. All right, this is the value of n. Okay, so we'll make a column like this, ni, and we'll keep status here at the side. Now what I'm doing in the next step, just watch. I am making status is equal to 1. You will know why I am using this status variable, also called as the flag variable. Okay, you will understand it as we proceed in the program. Then what I am doing next is, using the for loop, I am initializing I to 2. So the starting value of I is 2, number happens to be 31. Now, what is the last number that can divide 31? It can be 16 is the last number, or even 15 is the last number. That's why starting with the value of I from 2, as long as I is less than or equal to 16, I am going to try to divide this number by the value of I. So let us see what I am trying to do in this particular loop. All right, it will be quite simple after that. So what I am doing here is, I am trying to divide n by I. I is 2, n by 2 is happens to be around 16. 31 divided by 2, is the remainder 0? No. So I'll go here, I'll increase the value of I by 1. I ends up becoming 3. Now I compare again. 3 is less than or equal to 31 by 2, which is 16. Now 31 divided by 3, is it equal to 0? It is still false. I ends up becoming 4. 4 is less than or equal to 16. So what I am doing next is I am trying to divide 31 by 16. Is the remainder 0? It is still false. I ends up becoming 5. This way I keeps on going. Okay. 31 is not divisible by 6, 7, 8, 9, 10 and 11. Let's take the number 12 when the value of I is 12. 12 31 divided by 12, is the remainder 0? It's again false. Now I end up making it 13. Now what happens is I becomes 13. 13 is still less than or equal to 16. 31 divided by 13, is it equal to 0? It's still false. So I increase the value of I to 14. Now I increase the value of I to 14. Then what happens here is 14 is still less than or equal to 16. So 31 divided by 14, is it 0? Still false. So I'm going to come here. What is the next value of I? I is ended up going to become equal to 15. 15 is still less than or equal to 16. 31 divided by 15, is it 0? It's still false. Now I make I equal to 16. 16 is still equal to 16, so we are okay. 31 divided by 16, is it equal to 0? It is false. So I become 17. 17 is no longer equal to 16 and I come up. What is the value of status? Status is 1. So since status is equal to 1, I am saying that 31 is a prime number. Let me show you a case where it is not a prime number. The best way to take a look at that is flip this side and take another variable. Let's take n as 4 or yeah, we can take any number. Let's take 12. N as 12, I with 2. All right. I is 2. 2 is less than or equal to n by 2 is 6. All right. So I'm coming into this division. Now what is happening here is 12 divided by 2, the remainder is 0. So I am making this particular memory location or variable equal to 0. Whenever it's a prime number, I'm ensuring that, not a prime number, sorry, I'm ensuring that this status becomes 0. After that, I'm saying it is not a prime, and because of this break statement, I am coming out of this particular loop. Once I come out of this loop, status is 0, so it will not do this particular if statement execution. So let's take one more number and then you will get a better feel of it. Let us take a number, let's say 9, yeah, 14, yeah, let's take a number, say 16. All right, or 16 also is an even number. So let's take a number which is odd and happens to be a prime number. 21. Let's say number is 21. I is 2. Status is 1. 21 by 2 is approximately 11. 21 divided by 2 equal to 0. This is false. I now ends up becoming 3. 3 is less than or equal to 11. 21 divided by 3 is equal to 0. Status becomes 0. It is saying it is not a prime number. That means 21 is not a prime. It is because of this break, you're coming out of this particular block or loop and stopping in the program execution. Now you need to understand one particular thing here. When you're using this break, the reason you're using this break is once you found out that the number is not a prime, there is no point in checking with other divisors. So it saves you extra or wastage of computer time. Now, let us come and understand the break statement. Now it's really easy to understand the break statement. So break statement is used at multiple places. For example, you have used it in the switch case statement to come out of that particular switch case label. Break causes the immediate termination or exit of the loop. So after it's a break, it will come out of the loop. Now once it breaks, the program resumes at the next statement. Next statement is here. Once it hits the break, it will come to this if. It will check the if. If the if is true, it will execute it. Otherwise, it won't execute it. This is the syntax of break using an example. Now what I am doing is I am starting from n equal to 0, n less than 10. I am printing the value of n. So it will start printing from 0 to, even it will even print 10, because after 10 I am doing the condition check. Once it prints from 0 to 10, when the value of n becomes 10, it will do a break. It will come out of this loop and it will no longer print any numbers after 10. So I hope you have understood what it really means to use the break statement in your loops.